Pythagorean Theorem. If you can take your notebooks out and write down the two essential questions. The first one is, what is the Pythagorean Theorem? And the second is, why do we need to use it? Alright, so class, before we actually get into the theorem, is there anything you guys know in general about triangles?
They have three sides. All the angles add up to 180 degrees. Some angles are right triangles, and some are acute triangles. And some are obtuse.
Very good, Taylor. We are actually going to be focusing on the 90-degree angle in a little bit, but we are going to talk about the history of the theorem. The philosopher and mathematician, he was Greek, and his name was Pythagoras, and this theorem is actually the earliest known theorem for the ancient civilization. And before we get to this, we're going to watch a little video about the Pythagorean Theorem. Are examples of right triangles. Can someone tell me how we know that they are a right triangle?
They have 90-degree angles.
Yes, perfect. And how we know that they have a 90-degree angle is this triangle, or square, right here. Whenever there's a 90-degree angle in a triangle, they usually won't mark it by putting the 90 degrees, but they'll put the square instead, and that's just known that will represent the 90-degree angle. So the actual theorem is a squared plus b squared equals c squared. Now the a and the b represent the legs of the triangle, and the c will represent the longest leg of the triangle, which is also known as the hypotenuse. All right, there is some technical difficulties transferring from my laptop to this computer, and so I have the printed off copy. I'm just going to read you the key terms, and then you can either write it down in your notebooks, or I'll give you a printed sheet of the key terms for next week, because you will need this in a couple weeks when we take our exam. So area, the number of square units needed to cover a surface. Parameter, the sum of the lengths of all the sides of a polygon. The Pythagorean Theorem, used to find the side lengths of right triangle. The Pythagorean Theorem states that the square of the hypotenuse is equal to the squares of the two sides, or a squared plus b squared equals c squared, where c is the hypotenuse. In the right triangle, a triangle containing an angle of 90 degrees. Here is an actual representation of the theorem. This is one of the legs, because it's the A, and the other leg is the B. And if you notice that the C is the hypotenuse, it's the longest leg of the triangle, and it's also across from the 90-degree angle. The theorem suggests that this leg squared plus this leg squared will equal the hypotenuse squared. And so in the next few minutes, we're going to try to prove this. So here are some triangles, and we're going to do the first one together and also the second one, and then on the third triangle, I'm going to see if you can actually figure it out by yourself, and I'll be here in case you need help. So the first triangle is going to have 4 and 3, and we have to figure out what C is, C squared. And the 4 will represent the A, and the 3 will represent the B. So if we come and get our calculator to figure this out, we can write it out in the theorem, which is 4 squared plus 3 squared equals C squared. So if we square the 4, that's 16, plus 3 squared, which is 9, equals C squared. Then we take 16 plus 9, 25 equals C squared. Now you take the root of 25, and that will equal 5. So C equals 5. Now will you do the next triangle, which is triangle 2. This side is 24, and this side is 7. So to begin, we'll start out with our theorem. 24 squared plus 7 squared equals C squared. Remember, this is A, this is B, and this hypotenuse will equal C squared. So we'll go over here, we'll square 24, 576, plus the square of 7, 49 equals C squared. We'll add those two together, 576 plus 49 equals 625. We have to find the square root of 625. And that equals 25. C will equal 25. Now we're going to go on to this triangle, and number 3, I'm going to have you guys take out your notebooks and work them by yourselves or with a partner sitting next to you. And if you guys have any questions, raise your hands, and I will try to answer your questions. All right, class, now that you've had time to figure out, is there anyone that wants to volunteer to work it out on the board? Taylor, do you want to come work it out?
Yes.
Okay, so there's the formula, and then does it matter which side is A, which side is B?
No.
Okay. Okay, Okay, so I did 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared. So 169, I'm going to put it over here, equals c squared. So c equals the square root of 169, which I think is wrong up here. 13. So c equals 13.
Good job, Taylor.
We have talked about the theorem and worked some of the problems out together. We are going to have a little quiz. And like I said, there are some technical difficulties, and so this was supposed to say equation. So for number 1, if you could just work or show me that you know the theorem. And then for 2 through 5, you can label it 2, 3, 4, and 5. I want you to find the hypothesis, which will be C. And you can do that in your notebook. You can just tear out a piece of paper